What is up everyone, and welcome to our course on JavaScript 101. My name is Nemish and I'll be guiding you through the next 2 to 3 hours in which we'll learn the basics of JavaScript and how to build up a simple game together. So what are we going to learn specifically? Well, we'll start with coding basics using JavaScript syntax. So this will be a way to get our hands dirty with JavaScript syntax while exploring some basic coding concepts. Here we'll talk about the language features and the general concepts such as conditionals, loops, and objects and classes that we'll need to build up our games. After this, we'll move to the game development portion, specifically with JavaScript. Now, we're going to be using JavaScript's game engine, which is a little different from some of the others out there. So the techniques that we'll be using will be applied specifically towards JavaScript. So we'll divide our course into 3 distinct parts. The first will deal with just the JavaScript language basics. Again, this will be getting to know the syntax of JavaScript specifically, and then we're going to use that to explore some coding concepts. We'll then talk about the game development basics. This will be learning the different components we'll need to piece together a simple game. And finally, we'll build that final game as kind of an end course project. So what do we need going in? Well, actually not a whole lot. We're only expecting that you have some experience with HTML and CSS, so it's not like you need to be a master at either of those 2 languages to proceed. We are assuming that you know how to set up a basic HTML page, some simple CSS styling, although we'll try to kind of steer away from any complex styling, but we are expecting that you have no experience with JavaScript. We're going to be approaching everything from a beginner's perspective, so if you are very familiar with JavaScript, you may find this a little slow. We also don't expect that you have any experience with game development, and even if you do, probably you've never used JavaScript's game engine before. Now, you will need a text editor for the second and third parts of this course. I think for the language basics, you can pretty much get away with using something like JSBin or some online JavaScript compiler. But at some point in time, we will need to actually build up our web pages from scratch. Text editor will help. And of course, a browser. Now, I'm assuming if you are watching this, then you do have some kind of a browser installed and ready to use. But for the most part, we will be actually running our games by first writing the text in a text editor and then running on the browser. Now, how will these tutorials work? Well, that kind of depends on which part we're covering. Generally speaking, we start with an intro in the slides. Now, this just tells us what the topic is and kind of the subtopics we'll be covering within an individual tutorial. And then we'll take a look at some code examples. Now, all of these tutorials will be kind of a follow along over the shoulder style of coding, which means that I'll show you what I'm doing, I'll type things out in real time, and you can follow along. So for the first part, that's a language basics, I would recommend an online compiler like Rex Tester, or you can use JSBin or something similar. And for the second and third parts, I would recommend a text editor. There will often be a code challenge at the end of the tutorials. Now, not all of them will have a code challenge, but the ones that do will try to keep things fairly simple, and will provide a solution at the beginning of the next tutorial, just that you have something to work with and it's a bit more interactive. Now, finally, why bother going through all this trouble to learn JavaScript? Well, JavaScript is one of the most popular languages out there. It's used pretty much everywhere to power web and mobile apps, websites, games, and has even been applied towards machine learning and data science software. Everywhere you look, JavaScript is powering our devices. It's also very, very easy to learn, and there is a ton of support online. There are thousands of different discussion forums that discuss various JavaScript features and provide tons of support. So chances are, if you have a question, it has already been answered by someone, or it will be answered very shortly. So the final point is that all you really need with JavaScript is a text editor and a browser to run it. That means you don't have to download and install any fancy compilers or even deal with any command line tools. So that is it for our course intro. I hope you guys are very excited to learn about JavaScript and use it to apply towards game development, because it's a fantastic language to learn, super easy to use, and easy to get started. So let's begin with the very first topic. Thanks for watching. We'll see you guys in that one. What's up guys, welcome to the first of our 3 topics. This will be the JavaScript language basics. Here we're just going to get familiar with JavaScript syntax while learning some basic coding concepts such as variables, conditionals, functions, loops, objects and classes, and so on and so forth. So what are we going to cover specifically? Well, our list of subtopics starts with variables and strings. Likely we'll divide this into a section just for variables and one just for strings, as we're trying to keep the tutorials a little bit shorter, and also strings have a bunch of extra functionality, so it's important we cover them separately. Then we'll move to operators. There are tons of operators, and once again we're trying to keep things short, so likely this will span 2 or more sections. And then we'll cover arrays and dictionaries. Now we'll try to keep this to just one section for each of arrays and one section for dictionaries, because arrays actually have a bunch of extra stuff that we can talk about. This may need to be divided into 3 sections instead of just 2, but we'll see how long each one goes. Next up will be functions, parameters, and return values. This will definitely need at least 2 sections, one for basic implementing and calling of functions, and then another for the parameters and return values, how to add those into functions. Next up, we'll move to various control flow forms, starting with if statements and the variants, else if and else. And then we'll talk about while and for loops. No doubt we'll need at least 2 or 3 sections for this, because while loops are one thing, and then for loops are something a little bit different, and they'll have a variant as well, so we'll try to stick to the 2 sections, one for while and one for loops. Next up, we'll talk about break, continue, and return statements. These are just various control statements that can expand upon our if statements and while and for loops. And then we'll move to the final topic, which will be classes and objects. Now, I won't talk a lot about classes and objects here, but we will need at least a few sections to cover all of the nuances that JavaScript has surrounding classes and objects. There are lots of ways we can create them and use them, so we'll expand upon them more when we get to that. Okay, so this is a rough breakdown of the topics. Obviously, we'll talk more about what each one is going to bring to the table once we get to it. Now, before we jump right into variables and strings, I do want to talk a little bit more about how we'll perform these tutorials. So for the most part, the tutorials will be the over-the-shoulder style, but I'm going to just write my code in a text editor. What I'd recommend you do is use an online compiler. So if you switch to a browser, I'll just show you a few tools that you can use to run your JavaScript codes. The benefit of running your code is, of course, you actually get to see the results of the code you're writing rather than just kind of following along and trusting that what I'm saying is going to work. So there are 2 basic options. One is just a JavaScript compiler that will just run pure JavaScript code. And the second is kind of like a website templating tool. So let's explore the compiler first. If you literally just search JavaScript compiler, it will give you a few different options. So all of these items I think work. I actually haven't explored them all. I personally like to use Rex Tester. As you can see, I've used playcode.io before. If we just click on this, I'll show you really quickly what it's all about. So this is just a way to write and run JavaScript code. So this is the simplest program you could write. It just prints hello world. If you run it, it just goes ahead and prints out the value. So any variable that you wrap within these brackets after the print will be printed out to the screen like this. For example, if I want to print out the number 5, I can do so. If I want to print out true, I can also do that. Okay, and so on and so forth. So that's one way of writing and running your JavaScript code. Again, I will be writing just in a text editor. I probably won't be running so much. So if you want to confirm things, then this is one way to do it. Another way of doing it is to search for something like JSBin. I'm a big fan of JSBin. It's a great website templating tool. We're not interested in this HTML or CSS. We only care about JavaScript. Now, instead of running your print function to log anything, we're actually going to do a console.log, and then we put the value here. So, for example, again, if I wanted to log hello world, I could go ahead and open up the console window, and I can run this. Oh, this is actually going to give me an error. I think console should be lowercase, so let's go ahead and run that again, and then we go. So just ignore that error there, but essentially we get our items being printed out there. So similar thing, we can define any variables above. If I had variable I is equal to 6, okay, and I wanted to log that, okay, I can go ahead and run it, and it prints out 6 there. Okay, so that's it for here. I will use a text editor, Sublime Text. I really like it. It's just a good way to organize the code. Basically, I'll explain the concepts, write them out, give a few examples, maybe even provide a challenge for you guys. What I'd recommend you guys do is then switch to an online compiler like JSBin or Rex Tester, and then go ahead and run your code. to actually output the results. That's probably the best way of learning how to code, is just to try these concepts yourself and see what the actual outputs are. So that's it for now. We are going to move right into the variables section coming right up, so prepare yourselves for that. Maybe try a few of these compilers out, decide which one you like best, select one, and let's get started learning about variables. So thanks for watching. We'll see you guys in that section. What's up, guys? Welcome to the first topic in our JavaScript language basics. This will be devoted entirely to variables. We're going to explore what they are and take a look at two different types. So for starters, what are variables? These are simply a way to keep track of values and data throughout our code. Now, this will be something common to every single computer program out there. There'll be some list of values, some kind of data that we'll need to keep track of as it changes while the program runs. That's what variables are used for. Basically, to use variables, we simply assign a value to a name. It's fairly straightforward. We use the keyword var, stands for variable, and then we give a name, and then equals some kind of value. We can change that value unless we're using constants. Constants are declared with the const keyword or the let keyword. We'll explore that in a bit. And we're going to cover two specific types. Now, the type of a variable dictates what kind of data it can hold. We're going to take a look at numbers. These can be whole or decimal numbers. Some programming languages distinguish between the two. JavaScript is a bit more flexible. And then we'll look at booleans, which are just true or false values. So these are two different kinds of data that these two variables will hold. We often lump strings here, but we'll actually cover strings in the next section. So let's head on over to a text editor now. I am using Sublime Text for mine. As you can see, I've got a couple of files open. One is javascript code.js, one is old javascript code.js. These are both JavaScript files. The way I'm going to run things is I will look at the current code, and I'll put this in JavaScript code, and then once we finish the section, I'll just shift all that old code into this old JavaScript code file. That way we start from basically a clean slate here, but can keep track of all the old code that we've written. Okay? Once again, if you do want to actually run your code, I'd recommend that once you finish writing it here, you shift it to an online compiler or just write it right in the online compiler. Totally up to you. That's just a quick, easy way to run things. Okay, so let's take a look at an example of some variables. Now, we're going to try to use game development examples just so that we can launch right into our game development basics, and it's an easy transition. So let's consider a number variable and a true or false variable. Where might we see these within a game? Well, the first thing that comes to mind is going to be, when we're dealing with numbers, the health that a character might have. So we might want to declare a variable, var. You know how it kind of slants here. That denotes that it is an actual keyword. And we might create something called health. Okay. To assign a value, we simply do the equals and then some value. So we might start out with 100 health. We can add the semicolon. It's actually not necessary in JavaScript. Some languages do require the semicolon. So it's good practice. It also allows us to do multiple things on a single line. For example, I could create another one, current health like this, maybe 50. It's a bit messy, so I like to do things on different lines where possible. Okay, and here we basically have created two numerical variables. I could change this to a decimal value if I want. I could do, for example, only 50.5 health. I can also reassign any one of these. Maybe I want my current health is decreased in health a little bit, took some damage, so now I'm only at 40.5. Okay, note how I didn't do variable again. This is because my variable current health has already been created. Once a variable with this name has been created, we cannot create another variable with the same name. We can reuse this current one, but that is just using the same variable. It's going to change the value of this guy here. Now, one thing we can do is assign a variable the value of another variable. And so, for example, I could say my current health is now equal to my value of health here. Now, it's important to note the distinction between doing this and doing it the other way around. Health is equal to current health. Doing things this way, I'm essentially saying the value stored here is the same as the value stored here. So in this case, current health is equal to 100. If I did it the other way around, if I did health is equal to current health, well, essentially I'm storing the value of this into this guy. And so this remains unchanged, but this changes. In the previous example, this remains unchanged, but this changes. Okay, so it's important to note the order in which we're doing things. Now, we probably wouldn't want to actually do this because the value of health might be something more like maximum health. So let's actually change that to max health. Okay, and that way we can change this guy too. So max health, realistically, should probably be a constant. Let's say that throughout the game's execution, that is never ever going to change. We will never have more than the max health. We cannot increase or decrease it in any way. We can only change the current health. Well, for that, we can use let to indicate a constant, or we can use the constant keyword. Either one does essentially the same thing. It doesn't allow this value to change. So I couldn't then do something like max health is equal to 50. That's going to give me an error. Same thing if I used let. The difference between the two is kind of contextual. We would use a constant for maybe like a physics constant, like gravity or the speed of light. Whereas if it were just using kind of an in-program constant, such as max health, perhaps let is the more appropriate word to use. So I'm actually just going to change it to max health here. By the way, in case you haven't seen this before, this is what we call a comment. Anything after the double forward slash is essentially ignored by the compiler. So even if your program had 100 statements like this, as long as they have this in front of them, the compiler completely ignores them. They're really just there for us to read. I think what I'll do at the end of this is kind of add comments to each of these guys explaining what the output value will be. Like, it's easy to see that this will be 40.5, maybe not so easy to see that this would actually be 100. Okay, so that's kind of what I'll try to do there. Alright, so that's numbers for you. Again, decimal or whole numbers doesn't really matter. We can reassign them or use them as needed. So the other variable type I wanted to talk about is going to be the Boolean variable. Let's just see what time we're at. Okay, I'll try and speed this up. So Boolean variables just represent true or false values. They're super straightforward. An example would be checking to see whether the game is over or not. So we could do something like variable is game over is equal to true. Okay, later on, I guess while we're playing the game, it would be equal to false. Let's say some event triggers, maybe we touch an enemy and that causes us to lose the game. We can then say is game over is equal to true, and then we could maybe trigger some kind of end game logic, such as displaying the end game screen, maybe subtracting a life, so on and so forth. These are super straightforward though. If they're not true, they're false. If they're not false, they are true. So, fairly straightforward stuff, just the two variable types. Now, that's pretty much all we wanted to cover in this tutorial. A little bit of homework for you guys if you want to try to do this before the next section. Try to think from a game standpoint. One more variable that we might represent using a number type, and one more variable that we might represent with a Boolean. So some numerical value you might find in many different kinds of games, and some true or false value that you might find. I'll go over an example or two that I come up with at the beginning of the next section. Otherwise, thanks for watching. We'll see you guys in the next one. We'll be talking about string variables. What is up, guys? Welcome to part 2 of our JavaScript language basics. This will be on the topic of strings, and it's essentially an extension of the variables tutorial. So what are strings and how are they different from numbers or booleans? Strings are simply another kind of variable that's used to represent a different kind of data. So instead of numbers or true or false, we're going to use strings to represent anything textual. So this could be just general text within our program, this could be any message that we need to output, this could be the name of a character, etc. Anytime you need anything text related, we're going to stick it inside of a string. Now, while looking through the code, and from a code standpoint, a string is simply anything between the quotes. This could be double quotes, this could be single quotes, or as we'll see, in some cases we'll need backticks. I'll show you what the backtick character looks like, and it's pretty specific in its usage. In fact, in some compilers it's actually not even recognized, which is annoying. But for the most part, JavaScript isn't really picky which one of these you use, as long as you're consistent throughout. So let's head on over to the code and we'll see some examples. Now, before we move to strings, let's take a quick look at a solution to the previous challenge. That was just to come up with another numerical and another Boolean variable. I came up with the numerical variable number of lives equal to 3. We'll often want to keep track of the number of lives that a player currently has. Also came up with a Boolean variable is at the end. It's not the best example, but it's just a way to check to see if we're at the end of the level, so that maybe we can move on to the next one, or we can't go any further right. Okay, so that's just a couple of examples. Let's get back to the task at hand. Okay, so the first thing that comes to mind when we're dealing with text data might be a character or level name. So to create a string variable, we follow the same syntax. It's a variable and then the name. Maybe we'll have character name and then some kind of value between the quotes here. So again, could be single, could be double quotes, could be these backticks. Okay, for those of you who haven't seen these before, this is on Macs, the top left key just below escape. I'm not 100% sure where it's found on Windows, but we will be using these characters at some point. So I'm just going to provide a value here. I'll use my own for now. Like before, I can change this if I want. I could set character name equal to some garbage. If this was a constant, however, I couldn't change it. This would not be allowed. I do want to maybe be able to change it at some point in time. Maybe let's change it to something actual like Zenva. Okay. So aside from names, some other places we might see text in our code would be in messages that we output to the screen, or perhaps in speech that our characters are speaking. So there might be like a welcome message or something like that. Let's make a constant called welcome message. Okay. And you know what, let's actually just call this message just so it's not going too far off the screen. And then let's put some value in here. So this could just be hi, my name is, and then the value. Now strings are a little weird in that there's actually a couple of ways we can feed values in. We can use the plus operator, which we'll actually cover in the next section, so let's ignore that for now. The second way is to use what's called string interpolation. So this is where we essentially feed a value directly into the string while still within these quotes. So in my case, I want to feed in my name variable, character name, okay, and I want to put it right here. Well, for this, I'm going to use string interpolation, and the way we do that is with a $sign, these curly brackets, and then the variable, so character name. Now this is getting kind of zoomed in, so let me just zoom out a little bit. So we have character name here, like so, and this right now would just output this string literal. Because we're doing interpolation, I have to use these backticks, like so, and so you can see this has now changed color. So it's a Sublime Text thing, it just changes the colors here. So instead of saying my name is $ curly brace character name curly brace, this is going to say my name is Nimish because it gets to this. It says this is definitely interpolation. And so we need to feed this value or whatever is stored at character name. In fact, it's actually Zenva. We need to feed that into this variable right here. Similarly, we can go one step further. Let's say we want to say, hi, my name is so-and-so, and my age is so-and-so, okay? For that, we'll need an age variable. Maybe we'll set this to 26. And we'll say, and my age is, and then whatever value age takes on. So I could do this. So it doesn't matter what kind of variable we're dealing with, string, number, etc. We can feed them right into the string through string interpolation. Just be sure that if you are doing interpolation, you use these backticks instead of just single or double quotes. Now, as for this, I actually do want to put these on multiple lines, so I'm actually just going to do that so that you can see the whole thing. Now, because strings are kind of special variables, there's extra functionality attached to them. This allows us to retrieve properties or modify strings in some way. For example, I can retrieve the length of a string by doing something like, actually let's make this a constant, length equal to my string, so in this case character name dot length. This is going to look at this, it's going to say, okay, 1, 2, 3, 4, 5, and then it's going to store the value 5 in here. There are some other things I can do, for example, convert a string to upper or lowercase using the to uppercase or the to lowercase function. I could do something like upper name is equal to my character name dot to uppercase, like so, and this is going to take Zenva and it's going to make it into Zenva, like so, okay? Similarly, I can do the same with lowercase. Let's lower name equal my character name dot to lowercase. Now, in all of these examples, it's not modifying the actual original string itself. So this means that my character name stays the same, it's still Zenva. Even here, it's still the same. We're basically just making a copy and converting it to uppercase and storing it in here. If we wanted to change the original, what we would have to do is say something like character name is equal to its current value and then convert it to uppercase. Because this is again just getting the value, make it to uppercase, and then storing it in whatever we're putting here. So this is back into the original. So the final thing I want to do is talk about string slices. This is often referred to as substrings in other languages and is something that we'll very often want to do. This is essentially taking a part of a string out of the original one. It still leaves the original string exactly as it was before, it just retrieves a portion of it. Let's say, for example, I wanted to retrieve Zen from Zenva. What I could do is I could create a variable that's just called the Zen. And I'm going to set this equal to my character name, and I want to get a slice from it. So slice like this. Now in here, I need to pass in a start and an end index, because I want the first 3 characters. My first index start is 0, 1, 2, and 3. So essentially, I want the 0th index, and I'm going for the first 3, so 0 and 3, and that will fetch me my value of Zen. Okay, so that is pretty much all we wanted to cover. Again, character name remains unchanged for this. It's still just a Zenva, but by the way, it is lowercase, so it will be Z-E-N, Z lowercase. Otherwise, you now know how to use strings, so you know how to represent numerical data, Boolean data, and text data now. I'm going to leave you with a challenge. Hopefully we have time. Yes, we do, just enough time. What I'd like you to do is keep track of levels and print out a title that contains the current level we're on. So what we'll need is a variable to keep track of which level we're on, 1, 2, 3, etc. And then we'll need a string that will print out just level and then whatever level we're on. Just as a hint, you're going to use string interpolation. You'll probably need the 2 variables to keep track of the current level number, and then the string which is going to say level whatever, and I'll provide a solution for that at the end of the beginning of the next section. Okay, so thanks for watching. We'll see you guys in the next one. What's up guys, welcome to part 3 of our JavaScript language basics. Here we're going to talk about operators. We'll probably have to divide this into 2 parts, but let's see what we can get done first. So what are operators? This is simply a way to perform tests or modify variable values. Now we're going to be covering 5 different types that will allow us to perform various operations throughout our program. We can use the assignment operator. This is a way to just take one value and store it inside of another. We've actually seen this in action already. We'll then move on to arithmetic operations. So these are the basic mathematical operations you might be used to: addition, subtraction, multiplication, division, but there'll be another couple we'll look at too. Then there'll be the comparison operators. These will essentially compare 2 values and return either true or false depending on the comparison we're performing. Are they equal, not equal, greater, etc. We'll then look at logical operators. This will be a way to test for additional cases. And finally, we'll move on to the ternary operator. There's just the one of these in most languages, and JavaScript is no exception. There are actually some other operators which we won't be covering as they're a bit more advanced and we don't really find ourselves using them very often. So let's head on over to the code, and probably we'll only have time for assignment and arithmetic in this one, and then we'll cover the other 3 in the next section. So this is where we left off last time. This is our JavaScript code that dealt with strings. I did challenge you to try to print out the title of a level based on a level variable, and this is kind of the solution I've come up with. So essentially we have a variable to keep track of the level, and we're just feeding it into this string via interpolation. Now, just as a side note, I think this character is not recognized in Rex Tester for whatever reason. I'm not really sure why, but if you did use JSBin or something like that, I think it is recognized there, so you should have had better results. So back to the task at hand. So we'll start with the assignment operator and then move to the arithmetic, and then we'll actually finish up with kind of a combination of the 2. The assignment operator we've actually already seen in action. This is just taking a variable and assigning a value to it. So for example, we could do something like health. Let's create that variable actually. Variable health is equal to, let's say, 50. Okay, and let's just zoom in. All right, good stuff. So this is the assignment operator. It takes a variable on the left, assigns a value on the right. We can again reassign this. We can do health is actually equal to 100, but we've already seen that guy in action. So now we move on to the more interesting ones. These are going to be the arithmetic operators. So these should be fairly familiar to us from basic math. These are going to be addition, subtraction, multiplication, division. We'll also explore the modulus and the exponentiation operators as well. Modulus is just used to return the remainder of a division, and this is used to raise something to the power of something else. They work exactly as you'd think they would. We take a value, we perform the operation with another value, and then store the results. So for example, I could do something like, let's just do this down here, health is equal to my current value of health plus 10. So it's just adding 10 to my value of health, and this is of course going to store 60 in it. Okay. Similarly, I can do the same with subtraction, multiplication, division, and so on and so forth. I do, however, want to demonstrate the modulus and the exponentiation operators, as they may or may not be familiar to you. So we could do something like health, right now it's equal to 60, is equal to the health value modulus, let's say 50. This is going to return us 10, because it's going to take 60, it's going to divide it by 50, and that's of course going to return us 10. So it would be, we'll return a remainder of 10, because 50 goes into 60 once and has 10 as the remainder. So that's what the modulus operator is doing. It's actually very, very useful. One common use for this is to determine if something is even. We can do that by doing something like health mod 2 is equal to 0. We'll talk more about exactly what this is doing, but essentially this is returning true if health divided by 2 will have no remainder, because if we divide something by 2 and there's no remainder, it's even. If it returns 1 as the remainder, then it's odd. Okay, so that's just something that we commonly do. In fact, I'm going to leave that and just comment it out. The other thing is the exponentiation operator. I'll just demonstrate it, but I'll comment this out because it won't really make much sense in our context. We could do, for example, health squared. This is just health raised to the power of 2. That would just be, actually this is 60. No, this is the modulus, so it's actually 10 right now. So that's 10 squared. Yeah, that equals 100. I guess we can leave that in. So that currently has the value of 100. So we've seen the assignments, we've seen the basic arithmetic. It's time to combine the two into these kind of set of arithmetic assignment operator combinations. Now these may look weird, but they're actually fairly straightforward. Essentially all they're doing is they are taking a current variable and reassigning its value. These are going to be our plus equals, minus equals, multiply equals, and divide equals. Okay, so I'm just going to separate them with commas here. To see them in action, essentially they simulate something like this. Okay, so my health is currently 100. Let's say I want to subtract 20 from it. What I could do is do health minus equals 20. This is exactly the same as doing, let's do a comment here, health equals health minus 20. It's doing exactly the same thing. And we get the same results, the same kind of concept if we did the plus equals, multiply equals, and divide equals. It's just basically a short form of doing something like this. Okay? Another thing we can do in JavaScript is the plus plus and the minus minus operators. These just increase or decrease a value by 1. For example, if I did health plus plus, this is going to increase it by 1. Health minus minus is going to decrease it by 1. Okay, so this is now equal to, I think, 81. Okay, so that is all of the operators we want to cover. The very final thing, yeah, we got time, that I wanted to go over is going to be the order of operations. Now I'm sure that you guys, or hopefully you guys all remember order of operations, BEDMAS, if you remember from school, that's just going to be the order of things. So we do brackets first, then exponents, then multiplication or division, depending on which order you learned it, and then finish off with addition or subtraction. Order of operations is definitely observed within code, but generally speaking, we do use brackets to make things a bit more readable. So for example, let's take this equation here. We'll do health equals, and then we want to do maybe health times 2 plus, that should be plus actually, health divided by 5. Okay, or something like this. Okay, I'm not actually going to run this. I'm going to comment it out because it doesn't really make much sense given our context. But essentially, the brackets are redundant in this case. We don't need them because the results are going to be the same. If we did something like this, it would perform the multiplication first, and then the addition. Same with if we did this, it would do this first, then it would do this first, and then it would add the two together. But it's much easier to read at a glance if we do this, because then we know, okay, brackets first, we do everything here, and then add them together. So even though it's not necessary, it's good practice to do this, to add the brackets in, just to make it a bit more readable. Otherwise, that's all we wanted to cover here. The homework I'm going to leave you with is actually a really simple task. All I'm going to ask is you to provide 3 different ways I can increase my health by 1. Okay, so using these operators, use whatever combination you want. You can get as fancy as you'd like, but just come up with 3 different ways to increase my health by 1. Okay, we'll go over that at the beginning of the next section. Otherwise, we'll move on to the second operators portion. Thanks for watching. We'll see you guys in the next one. What's up everyone, welcome to part 4 of our JavaScript language basics. This is the second part of our operators topic. Here we're going to be studying the logical, conditionary, and ternary operators. So let's head on over to the code. And this is where we left off last time. So we talked about the assignment, the arithmetic, and the combo operators. So at the end of the last section, I left you with the challenge of coming up with 3 ways to increase health by 1. This is kind of what I was thinking. We can use the plus plus operator, we can use the health equals health plus 1, and then the plus equals. No doubt, I'm sure you came up with some very creative ways to do this, but as long as you have some of these, then we're good to go. I did actually forget to mention in the previous section that we can add strings together just like we can add numbers together. For example, if we go to our JavaScript code, start on a blank page, let's say we have the one string which is hello, so we can have variable hello is equal to hello like this, and then we have variable world is equal to world like this. We can do something like variable result is equal to hello plus world, and that will stick this guy right onto the end of this guy. Same thing goes with the plus equals operator like this, or like this rather. It works in exactly the same way. It can be used to stick strings together. So just a heads up, wanted to point that out before we move forwards. Okay, so we're going to be starting with the conditional operators. These are going to be our basic greater than or equal to, less than or equal to, is equal to, not equal to, and we also have the is equal to and is of the same type. Now we're not going to worry so much about this one as we'll need to learn more about different kinds of objects, so we'll ignore that one. But we'll focus on these. Now these are fairly straightforward. No doubt you've seen most of these, at least these guys, at some point in time. Essentially they perform a test to see if, for example, one value is greater than another, or if they are equal or not equal, and then we'll return true or false based on the results. So let's say we have a couple of numbers. So we'll just create a variable number 1. It's going to be equal to 5, and we'll create another one, number 2, that's going to be equal to 10. Well, if we do something like variable result is equal to number 1 greater than number 2, we're going to get false every time, because 5 is definitely not greater than 10. This is actually another way to assign a Boolean variable. Because this will return either true or false, in this case it's going to return false, it's going to be stored in a Boolean format, so this will in fact be false. Now the same thing goes with the greater than or equal to. The less than or equal to, is equal and not equal. For example, we can say result is equal to number 1 equals number 2. This once again will return false because the two values are not equal. If we did something like not equals, this will return true because, of course, the two values 5 and 10 are not the same. Now, so far we've just been comparing numbers, but we can absolutely compare strings. For example, let's say I have string 1, and it's equal to hello, and then I have variable string 2, and that's equal to world. I could do something like result is equal to string 1 equals string 2. Now this once again will be false, as the two strings are not equivalent in value. So that's our comparison operators, fairly straightforward. Again, just return a true or false result. So the next set of operators are going to be our logical operators. These are somewhat more complex. This will be our OR operator, the AND operator, and the NOT operator. In fact, let's start with the NOT because that's probably the most simple. Okay, and then we'll move on to the other two. So our NOT operator is a way to reverse a Boolean value. Result right now contains the value of false because we've assigned it string 1 equal to string 2. So we could say result is equal to not result. This is essentially just going to reverse it, so if it's false, it will become true, and if it's true, it will become false, so very straightforward. Also, by the way, note the double equals and the single equals. So single equals is assignment, double equals is comparison always. I think that applies to almost all programming languages as well. Now the other two operators are ways to test additional Boolean cases. So this is again going to return true or false, as is the case with all of them. This gives us the option to, this and this actually, both give us the option to test multiple cases. For example, we could say something like result is equal to number 1 greater than number 2, and string 1 equal to string 2, like so. And let's just zoom out. Okay, there we go. So this is going to test this case, is going to return either true or false, and then it's going to return this case, and again it will return either true or false. The caveat with the AND operator is that both of these have to return true in order to store the result of true. So if either one of these, or both of them, return false, then we store the value of false. So in this case, number 1 is not greater than number 2, that's false, and string 1 is not equal to string 2, so that is also false. Therefore, result stores false. Let's now change number 2 to equal number 1, so the two are equal in value now. What if we did something like this again? The result is still false actually, because even though this is, well, I guess this is actually still false, so let's do something like this. Even though this returns true, this still returns false, so we get an overall value of false. However, if we did something like, if we used our OR operator, only one of the two cases needs to be true. If both of them are true, then we're good to go. Or if only this or only this is true, then we'll also store the result of true. So in this case, we get false. In this case, we actually get true, I believe, yeah, because we assign it to false. And in this case, we get true stored, because at least one of these is true, specifically it's going to be this guy. Okay, so those are our logical operators. So far we've done conditional and logical. The last one we want to cover is the ternary operator. There's actually only one, and it kind of looks like this. Okay, you may or may not have seen this in other programming languages. Some other languages have an and, an or else or something like that. I think Python has an else instead of the question mark and colon. Anyway, this is what it looks like in JavaScript, and the way it works is we test some condition, the question mark, and then we have result A and result B. So result A will be the value stored if this returns true, and result B will be the value stored if this returns false. Now that may be a little confusing, so let's take a look at an example. We could say result is equal to number 1 greater than number 2. This is our test. We're seeing if number 1 is greater than number 2. So if number 1 is greater, perhaps we'll want to store that. And if number 2 is greater, perhaps we'll want to store that. So actually I think I zoomed in a little too far there. So this is going to test this. It will return either true or false. In this case it will return false because the two are equal. And so we'll store the value of number 2. However, if we did something like this, then we're going to store the value of number 1 rather than number 2. This works a little bit like an if-else statement. If you've ever been exposed to if and else statements, it's essentially if this is true, we'll store this result. If this is false, we'll store this result. So that's how our ternary operator works. Now, that's basically all we wanted to cover here, and we're just going over, so I'll end with a quick challenge. So essentially what I want you to do with this challenge is build a system that will determine whether the game is over or not based on the number of lives you have. So essentially we'll need to make sure that we're testing to see if our lives is greater than 0, and if it is, then we're going to store the value of is game over equal to false, okay? And if we don't have more than 0 lives, we'll store the value of is game over equal to true. So try that out. You should be able to do it without if statements. Just think about what your tests are going to return. Again, every test is going to return either true or false, and that's the value we're storing. So give that a go, and we'll give you a solution in the next section. So thanks for watching. See you in the next one. What is up, guys? Welcome to the 5th part of our JavaScript language basics. This will be all about arrays. We're going to be covering the basics of what arrays are and how to use them. So what are arrays? These are simply a way to store multiple values within a single variable. So we set them up and can treat them like a regular variable, except that instead of storing only one value at a time, we can store multiple values. If we want to access the individual values within an array rather than the whole array, we can access items based on their index. Now, indexing in JavaScript, as in most languages, is zero-based, which means the very first index is index 0, not index 1. Now, arrays also come with various operations that will help us to either retrieve properties of the array, such as the length, or modify the values in some way, such as adding or removing items from an array. We can also have multi-dimensional arrays. These are considered matrices, and essentially, instead of having individual values at each index, such as 1, 2, or 3, or some strings, we're going to replace those individual values with a whole array. So essentially, we just have arrays of arrays. Now we'll explore those and more in this section. We may need to span 2 sections depending on how much time we have, so let's jump right in and get started. Now, a solution to the previous section's problem, which was to create a system that will check to see if it's a game over, depending on, based on the number of lives we have, and return either true or false. I have a solution for that right here. So it's really simple. We just need to check to see if the number of lives we have is greater than 0. In this case, we have a variable here. This variable is 3. It is greater than 0, so it will return true. However, is game over shouldn't be true, it should be false because we want to keep playing, so that's why I added the not here to just reverse that. Okay, so this works to check to see if we have enough lives. Now I'm just going to comment out all of that stuff, and let's get to the task at hand. Okay, now like I said, arrays are set up just like regular variables. So we start with a variable or a constant, and actually I think that's a bit too zoomed in. And then we just put in a series of values within these brackets. Now we can have any kind of values we want: numbers, booleans, strings. We can have custom objects. We can have a mix of all of them, but we'll try to keep our arrays to one type only. So we'll take a look at arrays of strings. And one of the places we might see strings would be if we're building up, let's say, an inventory. Very often our games will have a character with an inventory. So let's create an inventory now. And it's essentially just going to be a list of inventory items, which will be strings. So what might we have in our inventory? Well, we might have, I don't know, like a shirt. We might have maybe, let's say, like an axe, some kind of a tool. We might also have some kind of food, let's just say bread. Okay, so I think that's a bit too zoomed in. We want to be able to see the whole thing there. So just like a regular variable, we can change it to something completely different. Let's say we want, I don't know, some water, and we want some pants or something. We can totally do that. We can change the array to something completely different. Unless, of course, it's a constant, in which case we cannot. So within our array, we know that we can access it just like a regular variable, but if we want the individual items, we have to access the index of the item. So with arrays, the order of the items is important because we access them based on their position. This means we don't necessarily know what item is at what position, which is why there are so many different search functions. Okay, so let's just pretend that we do know exactly what's in this array, and let's say we want our shirt. So this is going to be the item at index 0. We get that by doing inventory, and then the square brackets beside it with the index in it. So in this case, index 0. So we could say shirt is equal to the item at inventory index 0. It's important to note there's actually no built-in array bounds check, so if we did something like index 5, which doesn't exist, this is just going to silently throw an error. So always make sure that we have enough members in our in our array rather, to make sure that we're not going out of bounds. Okay, so we know how to retrieve an item at a certain index. What about modifying it? Well, for that, we can simply do the reverse. We could do inventory maybe at index 2, so this is going to be the last item, is going to be equal to something else. So instead of bread, let's have, I don't know, cheese maybe. Okay, so that's how you can access and modify individual elements. So we're about 5 minutes right now. I think we can go over some special array functions, and then we can save the multi-dimensional arrays for the next section. So I'm actually only going to take a look at 2 functions specifically, although, well, let's do 3 functions, although there are many more that you can access. So one is going to be a way to return the length. That's as simple as calling upon the array name and then getting the length property. So in this case, this will return us 3, just like we did a string length. In fact, because this is an array of strings, we can get the length of each item. So we could do something like inventory at the index of maybe 1. Let's change it up. We'll still do index 0.length. And that is going to give us the result of 5. And that's because shirt has 5 characters in it. So let's say length is equal to this, and then we'll just say length is now equal to this. Okay, cool stuff. So the second function I want to look at is going to be a way to add items to a list. This is through the use of the push method. This basically just takes an item and sticks it onto the end. So if we did our inventory.push, we just need to enter in another item. So we've got shirt, we've got axe, we've got cheese at this point. Let's add in maybe water or something. So this is now going to stick water onto the end of our inventory. So our inventory looks like this. Shirt, axe, we actually have cheese here, and we also have water. Cool stuff. So that's the push method. It always sticks it onto the end. Well, if you can add items to an array, you can remove items from them. And that's done using the pop method. So we can do inventory.pop like this, and this is going to remove the last item. Now there are methods to remove items at specific indices, but we won't explore those here. For now, we can just basically pop items until we reach the one that we want, and then push them back on. Now inventory.pop is going to do 2 things. It will remove the final item, so in this case water, and it will actually return it. So what I could do is I could say variable water is equal to inventory.pop. So not only does the inventory now contain only these 3 items, but water variable also contains this string water. Okay, so pop is doing 2 things at once. So that is pretty much all we want to cover. We are almost at the very end. We only really dealt with arrays of strings here, but like I said, you can have arrays of any type. Now, before I issue the challenge, we're actually going to end this, go to the next part, which will be multi-dimensional arrays, and then I'll give you your challenge at the end of that section. Okay, so stay tuned for that. Thanks for watching. We'll see you guys in that one. What's up everyone, welcome to part 6 of our language basics. Now we're going to be covering multi-dimensional arrays. This is a direct follow-up to arrays, so let's jump right in. Now multi-dimensional arrays we know are just arrays of arrays, so that means instead of each member being a single value like we saw with this stuff here, each member or some of the members are going to be arrays themselves. So, a simple example would be maybe if we're keeping track of all of the levels that we've covered. So we'll create a levels variable, okay, which is going to start off being an array, but instead of just containing, let's say 1, 2, 3, etc., it's going to contain a bunch of lists. So we'll have an array here, here, and here. So we can have basically an array of 3 arrays. So within this, we could do maybe like 1.1, 1.2, 1.3, okay? Maybe we'll do 2.1, 2.2, 2.3, and 2.4. And we'll finish this guy up with 3.1, 3.2, and let's leave it at that. So essentially here, we have a list, and each of the members is themselves a list. Now, at this point, you might be saying, well, how do we access a single value? Because we know if we did, for example, levels of 0, this would give us the first member in the levels list, or levels array, which will be this guy. But that's an entire array. So let's just actually store that. We could say first levels is going to be equal to levels of 0. But we want to go further. We want to get maybe level 1.2. Well, we could do this, and then say first levels of index 1. That would be one way of doing it. But if we want to do it all at the same time, what we can do is we can say variable second level is going to be equal to levels at the row of 0 and at the column of 1. Now it's important that we observe this order. It's always row first and then column. Okay, and that's kind of why I organize the list like this. by the way, list and array are interchangeable in this context. But that's kind of why I organize things this way, because we can think about each of these outer arrays, or I guess these are kind of inner arrays, as being a row, and then each of the indices as being a separate column. So it's row 0 and column 1. Okay? Now, these arrays of arrays or lists of lists are often referred to as matrices. You get pretty weird results if you've never done any kind of matrix algebra before when you start doing things like dot products and you start basically performing mathematical operations on these matrices. But I doubt we'll do anything that complex in this tutorial. We're really just teaching you the basics of JavaScript, getting you an intro into the stuff, so likely we won't be covering anything too complex. But this is essentially going to be our first array. Let me just annotate these guys for you. And this is going to be our second array, which will be, or rather our second member, which will be just this guy here. Okay. So, my challenge to you now is to try to modify levels in some way. So what I want you to do is try to remove an item here. Okay? Let's make it even more interesting. Let's have you remove item 2.3 just using pop methods. And I also want you to push an item another level, 3.3, onto the end of this array. So again, just to clarify, or rather just to restate, I want you to remove this guy using only pop methods and put 2.4 back on. So it should be 2.1, 2.2, 2.4 by the end. And then I want you to add a 3.3 onto the end of this guy. Okay, so you have your tasks, try to get that done, and in the next section we'll show you a solution and also introduce the notion of dictionaries. So thanks for watching, we'll see you in the next one. What's up guys, welcome to topic 7 in our JavaScript language basics. This will be all about dictionaries. We're going to learn what they are and compare them to arrays. So what are dictionaries? They actually function fairly similar to arrays because we're storing multiple values in a single variable. However, unlike arrays, each element has two components. Each element has a key and a value. So this is very different from arrays because instead of having just, let's say, 1, 2, 3 or some strings based at a specific index or position, dictionaries store items based on a key-value pair. So this means that each of the values stored at a key is what we're trying to access. And instead of accessing items based on an index of 0, 1 or 2, etc., we actually access the items based on their key. So with arrays, it was important to remember the order of the items if you want to know where everything is. With dictionaries, all we need to know is the key, and then we can access the values attached to those keys. These are often called mappings in other languages, so if you've heard that term instead of dictionaries, then that's essentially what that is. So let's go ahead and get started. I know it sounds confusing, but it's really not that bad once we see what we're dealing with. So I guess first things first, let's take a look at the solution from the previous section's challenge. I essentially wanted this guy gone, this guy shifted over, and I wanted a 3.3. And so I did it using this set of code here. Essentially, I just popped the first guy from levels, so this was level 1, and I just popped off 2.4 and stored it in 7th level. I then popped off 2.3, and then I pushed the 7th level onto the end of this, so it reads 2.1, 2.2, 2.4. At the end, then I just selected levels of 2, and then I pushed a 3.3 onto the end of that. So that's the solution I came up with. Hopefully you came up with something similar. Okay, so back to the task at hand, let's take a look at dictionaries. Now before we had an inventory of items, but that was just the item names themselves. Realistically, in a game, you probably have multiple of a single item, and it would be impractical to say, like, if say you had 3 shirts, to say shirt, shirt, and shirt. You'd probably want to have an item shirt, and say you have 3 of them. So that's what we can accomplish with a dictionary. Let's create another inventory, but this one will be a little more advanced. This one instead is going to be a dictionary rather than an array, denoted by these curly brackets. So these are often referred to as objects in some JavaScript courses. They're not quite the same, although they are very similar. I will explain the differences once we get to the classes and objects portion, but for now, just again, recognize that we're dealing with keys and values. So what kind of key do we want to use for each of these items? I recommend using the item name itself. We can access the keys, by the way, we don't just have to access the values, we can access the keys. And then the values is going to be the quantity that we have. So let's say we have a couple of shirts. Say we have 2 of these. Let's say we have an axe again. We only have 1 of these though. And let's say we have some bread. We have a few loaves of bread. Let's just do 3, whatever that would mean. 3 loaves, 3 slices, whatever you want it to be. Now for this example, I have my keys as strings and my values as numbers. There's no hard and fast rule about this. You can have your keys as numbers and your values as numbers. You can have your keys as strings, your values as strings. You can have your keys as booleans and your values as objects. There's no restriction as to what you can and can't have. Well, almost no restriction. Generally speaking, it's better practice to do a string key or a numerical key, but you'll see all sorts of dictionaries created. Now the next question comes in, how do we actually access the items, the keys, or the values? Well, the task is a bit easier for us because we know exactly what the keys and values are, but let's say you had no idea what any of the keys were. You can actually return a list of the keys or a list of the values by calling upon this function here, object.keys, okay, and then you pass in the item that you're trying to get the keys of. So in this case, it would be inventory. So this here will return you an array of keys. So we could say variable keys is equal to this. Similarly, we can get just the values. Variable values is equal to object.values of inventory. Okay. So we could get a list of shirts, axe, and bread, or we can get values 2, 1, and 3. Now that's good if we don't know what we're dealing with, but we do know what we're dealing with. We know exactly what keys we have. So let's say I want to see how many axes I have. So I can get my inventory, okay? And then instead of putting the position, in this case 1, we would actually put the key. So this would be axe here, and I could store this in axe quantity variable or something, num axes. Okay, and this would just be basically the quantity that's stored at this key, or the value stored at this key. So this just would give me 1. So let's say I want to add 1 more axe to our inventory. What I could do is I could say num axes equals, or actually I guess I would do inventory of axe, okay, equals 2. Now this is fine because I know I have 1 axe, but if I just wanted to add a single axe and I didn't know that I had 1, I could do plus equals 1. The danger here is that what if this key doesn't exist? Then I'm trying to access something and add 1 to it and it doesn't exist. That may or may not throw me an error, and the problem is if it throws me an error it will fail silently, which means I won't actually know exactly what the error is. So just to be safe, let's do equals 2. Okay, you could add in some logic to check to see if the key exists. For example, if keys contains this axe, okay, then we'll increase its value by 1, otherwise we won't. But you need to know if statements and stuff for that, and that's a topic for later on. In fact, I'm just going to take a quick aside and show you a method I probably should have showed you last section, but I'm going to show you here. So it's the includes method, and it tells you whether or not a list contains an item. So for example, keys.includes, let's say axe, will return true. Okay, because the keys does contain this word axe. So one of the keys is an axe. This is often contains in other languages. For some reason JavaScript went with includes, but they do the same thing. Okay, so this is another useful list method. So if you want to see what keys you have available, if you want to check to see if you have a key there, then you can do that. So otherwise, the nice thing about dictionaries is that if the entry doesn't exist, then it creates the entry and puts the value there. For example, if I did inventory of knife, we want to store 1 knife equals 1. It doesn't need to exist beforehand. This will just create a brand new entry, knife and 1, in our inventory. Okay? So that's pretty much all we wanted to talk about when it comes to dictionaries. The final thing I want to talk about is going to be when to use dictionaries and when to use just regular lists. Well, lists are position-based. That means it doesn't matter what's stored in the list. We are only concerned about the position. That's how we access the items, and that's based on their index. Whereas with dictionaries, we're interested in the key and value pairing. So the position of items in a dictionary doesn't matter at all. What we're interested in is what key those values are stored under. So essentially, if you're dealing with something where the position matters, probably a list or an array is the way to go. If you don't care about the order, but you want to know, you want to attach a value to something other than a position, so such as a key, then you'll probably want a dictionary. So that's it. I actually don't have a challenge for you guys for this particular one, because this is going to be very similar to the object tutorials, and we're going to be exploring this concept more within the object portion. Okay, so I'll save the challenges for when we reach there. Otherwise, let's move on to the next topic. Alright, so thanks for watching. We'll see you guys in the next one. What is up, everyone? Welcome to part 8 of our JavaScript language basics. This will be all about the topic of functions. We're going to learn what they are and how to use them. Likely this will take a couple of sections, so let's see what we can get done here. So what are functions? These are simply ways to store code and choose when and where we want to execute it. Now, how is that different from what we've been doing previously? Well, up until this point, we've essentially been executing all the code from top to bottom. With functions, we can store code in these functions, and then we can choose exactly when we want to execute it rather than executing it every time. We simply implement a function to specify which code we want to run, and then we call upon that function to execute the code within. Now this is important because when we write a function, the code within it actually won't run until it's called. So if that function is never called, the code will never run. We can also take values as input via parameters into functions and use them as variables. And we can also output values via a return value. Now likely what we'll do is stick with the first 3 parts of those functions points, and then we'll talk about parameters and return values in the next section. So let's head on over to the code and get started. So we're going to simulate some kind of a character health function, which is going to help heal our character up. So essentially what we're going to do is we're going to keep track of the character's current health, we're going to keep track of the maximum health, and we're going to have some kind of a healing factor that will help us to heal up a bunch. So let's have a constant called max health. This is going to be maybe 100. We'll have a variable current health, which will be maybe we're at 50% health. And we want a function that will help us to heal up. And so for now, although we will modify this later, let's have a healing factor. Let's say that this is 40. Okay. So what we're going to do is we'll start off with a function. So the way we declare a function is basically like this. We can do function, okay, and then come up with some name. So let's call this heal. Okay. And then within these curly braces here, this is where the function body goes. Now if we were taking parameters into a function, we would do so through these brackets here. Actually, let's kind of separate that out. So parameters go in here, and then if we wanted to output something, we'd do a return. But we'll worry about returns in the next section and parameters. For now, let's just get the basic function down. So this is fairly straightforward. Essentially what we want to do is we want to take our current health and we want to increase it by the healing factor. So that's straightforward enough. What we can just do is current health plus equals healing factor, and we can call it a day. So that's fairly straightforward. Essentially, anytime this function is called, we're going to take our current health, we're going to add the healing factor to it, and we'll call it a day. Now, important to note, again, because this isn't a function body, this code will not run. Our compiler will take note of this function, and we'll say, okay, anytime we call it, we'll execute this code, but we're not going to do anything about it until it's called. This is just a function implementation. To call upon the function, we have to call upon its name, in this case heal, and add the brackets beside it. If we had any inputs, we'd put them in here. If we had any outputs, we could store them here. Okay, so at this point, we would heal up, we would add the healing factor to our current health, so current health would be equal to 90 at this point in time. Now, that's actually really all there is to it. You have your function implementation, and you call upon it to execute it. So why bother with this at all, if in this case it's just one line? Well, that's true. This is a very simple function, which is really just an addition. We could do this without the use for function at all. But you can imagine when our functions get to 5, 10, 20 lines of code, it would be very, very tedious every time we want to heal our character to type that code out over and over again. Using this, a function, we can essentially just heal the character as many times as we want by doing this. In fact, we could just use a loop, but that's going to be something that we'll talk about in a couple of sections from now. So that's one of the main benefits. The second benefit is the fact that if we wrote that code out over and over again, if we wanted to make a minor change, such as by how much we're healing, then we have to change that code in lots of places. This way, if we want to change maybe the healing factor, all we need to do is change it in one place, or perhaps we would do a multiply equals or something like that. We only need to change it once, and it will execute all of the changes required throughout the rest of the code base. Okay, so where possible, put your code within functions and run things that way. In fact, if you were to actually write a proper program, that's most of the functionality is stuck within these functions. Now, you'll often see functions written like this as well. We could do the same thing, but turn it into a variable. So we could have something like variable heal is equal to this function. Both do exactly the same thing, okay? But in order to call upon heal, we do it this way, and in order to call upon heal this way, we do exactly the same thing. Alternatively, if the parameters are implied, or if there are no parameters, we can actually just do heal like this. We don't even have to pass in the brackets. It's a good idea to pass in the brackets anyway, because if we have parameters that we need to enter explicit values for, then we have to do that anyway. So it's good practice to add in the brackets. Now, one other thing that I should mention actually before moving on, seeing as we have the time, is the fact that we can nest functions. And so this is a function, but I can actually have a function within a function. So let's say for whatever reason, I have some function that is going to be like multiply healing factor or something, okay? And within it, it just multiplies a healing factor, but the only place in my entire code base, in my entire program, the only place I would use this function is within my heal function. But I may end up using it multiple times in heal. Well, for that, I would probably implement a nested function, such as we see here. So this nested function is actually not accessible anywhere else. As long as we're outside of these curly brackets, we cannot access this function. It can only be accessed from within heal. Okay? And then we could do whatever code we want to do here, and then we could call upon it here, multiply healing factor, except actually we call it after the implementation, but you get the picture. Okay, so we can nest functions if we figure that we're only going to need that function within another function body. Okay, I'm going to comment that out because we actually don't need it though. Now, this is almost complete, but we have one thing slightly wrong with this function, okay? And that is the fact that we can overheal. So let's say the healing factor is 60. Well, if we're adding 60 to 50, we get 110, which is more than our max health should allow for. So what I'd like you to do as a challenge is, using the ternary operator, try to figure out a way to prevent overhealing. So basically we'll cap out the healing at 100. And usually this would require the use of if and else statements, but the ternary operator basically does that, and we've actually seen the ternary operator in action. So try to give that a go, again preventing overhealing, essentially preventing your current health from ever going above 110, and of course I'll provide a solution in the next section. So in the next section we're going to be exploring the concept of parameters and return values. I'm going to comment that out because these two are doing the same thing, so stay tuned for that, and of course I'll provide a solution when we come back. So thanks for watching, we'll see you in the next one. What's up everyone, welcome to part 9 of our JavaScript language basics. This will be all about parameters and function return values. Now, seeing as this is a direct follow-up from the previous function section, we're just going to launch right in. Let's take a look at the code now, and we'll start with a solution to the problem. So if you remember, the problem was that we could potentially overheal, and we're trying to eliminate that. So I just commented out that current health plus equals healing factor, and I've added some more code. So the first thing I did was get the final health, which is just the current health plus the healing factor. So even if it overheals, we're storing the result in this variable. So then we're going to compare that variable to the maximum health. If it's greater than the maximum health, we'll just return the max health, because that's basically all we want to be able to heal, is up to full health. Otherwise, we'll do the final health. So basically, in this case, it's 90. this returns false, so we store the final health, which is 90. If it was, let's say, 110, then we would just output the maximum health there. So that way we would never store more than 100 in current health. Okay, so hopefully you came up with something similar. Otherwise, let's move on. Now, this function is only okay. It can definitely be improved upon. So the reason it can be improved upon is the fact that healing factor may or may not change, and that really depends on, realistically in a game, what items we're consuming to heal ourselves up. However, there's no need to keep track of that as a variable externally. What we can do is change this to a parameter so that we can just input it into a function. That way we don't have to keep track of healing factor, we don't have to see how it changes or remember to reassign the healing factor variable. All we need to do is input a value into function whenever we're trying to heal our character. So that's actually quite straightforward to do. Let's create a brand new function to represent that. So we can keep this one alive, but we're going to implement something else. This one's going to be heal by amount. And we're going to take in heal amount as a variable. And this way we can essentially ignore healing factor. What we can do is the exact same thing. So let's copy this code and we'll paste it in. But instead of using the healing factor, which realistically shouldn't be around in our code anymore, we can just use a heal amount. So once again, these two look really similar and actually act exactly the same, but this way we can basically comment this guy out. If we comment out this heal function, you know what, we might as well comment it out because we probably won't be using it. Okay, and we're just dealing with heal by amount. So we don't have to create a separate variable to keep track of some healing factor. This way we can just call upon the function, we can pass in this parameter, and it's essentially treated like a variable for the rest of this function. So because we have a parameter, if we want to call upon our function, we have to pass in a value. So if we do heal by amount, we have to pass in something. It could be 10, 20, could be 100. It's totally up to us. Let's just do 60 so that we can see that logic at work. Now, one thing I should note with parameters is that you can actually add in default values. So let's say I did healing amount of 10 as the default value. So this means that if for whatever reason I didn't pass in a value, I'm at least going to assign the value of 10. Okay, so this way the function, it will never cause me an error if I forget to pass in a value because we have the default of 10. If I did pass in a value, however, 60, it would overwrite this 10, and so heal amount would actually equal 60 or whatever I'm passing in here, rather than the default of 10. So if you think at some point in time you might forget to pass in a value, then add in a default value. If not, then just forget about it. Okay, so the final topic I want to talk about is return values. So this will be an output from the function once it finishes executing. So let's say we want to return the percent health that we have. So if we take in a healing factor of 40, that would be 90, so we'd have 90% health. That's easy enough to do. Essentially all we need to do is take our current health, divide by max health, multiply by 100 and return that. So we could just do return the current health divided by max health, and then we need to multiply that by 100. Multiply by 100 here, and that would give us a percent of health. Now, I know you're probably looking at me and saying, well, why are we dividing by 100 and then multiplying by 100? It's really about the context, okay? Because what if our max health was 150? Well, then we definitely need to multiply by 100, otherwise we would get an incorrect result. So even though this seems redundant, it provides better code maintainability. So what this is doing is it's going to output a value once we reach a return statement. So it's going to do this, it's going to do this, and then it's going to perform this, and it's going to output this value. So in this case, if we pass in 60, it goes to 100 because, again, we can't go over 100. So it changes to 100. So then we'd get 100 divided by 100 times 100, so 100% health. But if we passed in only 40, then we get 90% health, 80% health, 70, and so on and so forth. Okay, so this is going to be an output. So what we can do is we can either ignore the output or we can store the output. So let's say we want percent health to be equal to heal by amount. So we call upon this function, we pass in a value, it's used as a variable for these calculations. We're then returning the percent of health that we have left, and then we're storing that back in a variable. So you can see how functions are very, very powerful, or can be very powerful. I was just doing a fairly simple couple of arithmetic operations, but sometimes they'll be a lot more complex. As well, we also, if nothing needs to be changed about the function implementation, we don't even necessarily need to know how a function works. As long as it's taking the right input and producing the right output, we can treat it as almost like a black box. So, we're going to end with a little bit of a challenge here. So the challenge here is going to be to create a function that will calculate our percent health. Now, I know this is a very simple task. Realistically, your function is basically going to do exactly this, but it may need to take in a value, seeing as our current health may or may not be converted to a local variable or not. Okay, and it's going to need to return something so that we can call it from this function. You can make it a nested function if you want, or you can make it an external function. It's totally up to you. So again, there's just going to be a function to help calculate the percent health and then feed it into heal by amount. Alright, so I'll leave you with that. In the next section, we're going to be starting a different topic, so stay tuned for that. And of course, I'll provide the solution to this right away. So thanks for watching. We'll see you in the next one. What is up, everyone? Welcome to part 10 of our JavaScript language basics. Here we're going to be covering if statements and their variants. This will be a first intro into control flow in JavaScript. So what are if statements? There's a way to perform a test and run some code if that test returns true. So essentially, we'll get some value that is either going to be true or false based on a test. Is something greater than something? Is something equal to something? Etc. And then we get to execute some code if we get a true result returned. This is a way to add a certain amount of logic to our code. And there are some variants, including the else if statement. This will allow us to test for additional tests. The else statement, which will add a default value. So if all above tests fail, then we have a default test. And we can also nest if statements or use logical operators for additional tests. So there are definitely different ways in which we can combine various aspects of if statements to achieve some pretty complex logic. So let's head on over to the code to see some examples of these in actions. First things first, a solution to the previous problem. So I have it up here in the JavaScript code. And I just created this function called calculate percent health, and it's literally doing exactly what we had in this line. So I've just taken this line of code and put it in here. So what's the point, you might be asking? Well, if there were more complex calculations that needed to be performed, it would be very, very messy to have them all performed here. It's much better to perform them here. So let's say we wanted to calculate some percent health, we need to do something else, some other calculation up here, and then we needed to return this. It's much better to have it in its own function. Realistically, you want one function to do one job, okay? And you can kind of combine them in these ways. So this is going to perform this calculation and output the percent health, then it's going to get the result of that, and then this is going to actually be returning that value. Okay, so let's take this and we'll just stick it in here. Okay, so let's paste that there. I'm just going to comment this stuff out. And we can then get back to the task at hand. So let's just take this all and we'll clear it off. Now, if statements by themselves are actually quite simple. All we need to do is open up if. We want to test something, and then we have some code in here to execute if true. So generally the test here is comparing some values. So is something equal to true? Is something greater than something else? Is something equal to something else? And so on and so forth. So the example I'd want to use is going to be an example of movement. And we'll actually use some of this real logic in our code a little later on in parts 2 and 3. So what we'd want to do is essentially get a character and move him or her forwards. So we need to test to see if a certain key if a certain key is pressed, and that's going to move our character forwards. Now, realistically, you'd have actually listeners to listen for key presses, but we'll ignore that for now. Let's just say something like variable key pressed is equal to, and let's say it's right. So R for right, L for left, so on and so forth. So we're just doing the left and right keys. We also want an X position, so variable X position. Let's set this equal to 0, saying we're at the starting point. So what we want to do is we want to say if the key pressed is equal to right, okay, we are going to increase X position by 1. Now, this is going to perform this test, and it's only going to execute this code if this returns true. So if this is anything other than R, then this is not going to run. This is not put in a function, although I guess we could put it in a function called something like move character. But I figured we'd pull it out from functions just so we can focus on one thing at a time. So this should give us the result of x position equal to 1. Okay, and that's again because key pressed is equal to r. If key pressed was anything else, however, we have nothing happening. But we want something to happen. We want to move the character either left or right. So for that, we can introduce another case. So what we want to do is include what's called an else if case. So that's going to be something like else if key pressed is equal to left. Well, in this case, we want to decrease the x position by 1. So now we're starting to get a little bit more complex. We have two cases that we're testing for. We test first for this. If this returns true, then we execute this code, and we ignore this case. In fact, if there were any else ifs or elses after this, we ignore those too. So if one test passes, we execute the code and exit out. Now, if that test fails, then we ignore this code, and we move on to the next test. So we only test this if this fails. And then we perform the same procedure, check to see if this is the case. If it is, we execute this code, otherwise we have nothing else. Now at the very end of this all, we often have a default case, and this is if all of the above tests fail. This should probably be the case because there are many other keys other than right and left. So we'll have an else case. Well, this probably isn't a great mechanic, but let's say if we press anything else, we start right back to the beginning. So we're just going to say x position is equal to 0. This is just kind of a reset. So basically, we move right if the key pressed is right, so we increase x position by 1. We decrease it by 1 if the key pressed is left, and if the user presses anything else or does anything else, then the x position goes back to 0. We essentially reset. Once again, this case is only included if all of the above tests fail. Okay? Now this actually isn't performing a test. This is just saying, regardless of what happens, we'll execute this code if nothing else happens, if nothing else passes. Okay? So first test this. If it passes, execute this code and exit. If this fails, then we test this. If it passes, we execute this code and exit. And finally, we get to this one, which is not testing anything. It's saying, okay, everything above failed. We have to do something. We'll reset to 0. Now, let's see how much time we have. Okay, we're about 6.5 minutes. So we've got a few other things that we have to cover with regards to if statements. I'm actually going to end this section now, and we'll wrap up the if statements and the variants and stuff in the next section, just because I don't want this going any longer than it has to. Specifically, I'm trying to keep everything under 10 minutes. So we'll end it here. Now, no challenge for this section. We'll introduce a challenge at the end of the next section. Just try to think of some other cases in code where we might have if, else if, and else statements. And also note, by the way, we don't just have to have the one else if. We can have as many of these as we want, okay, before the else. Okay, so think about that. When we come back, we're going to talk about the other if, else if, and else statement variants. So thanks for watching. We'll see you guys in that next one. What's up everyone, welcome to part 11 of our JavaScript language basics. This will be some more if statement variants, and it's a direct follow-up to the previous section. So let's head right on over to the code where we left off. So this is what we covered previously. We took a look at the if statement, the else if, and the else statement variants. Now we're going to be taking a look at multiple concurrent if statements and comparing them to if else if. Then we'll take a look at nested if statements, and finally we'll finish up with logical operators. Those are those and the or operators. So, for starters, what is the difference between doing something like an if, else if, and doing something like this? If, and then another if. Well, if you remember, in this case, this test is only tested if this previous test fails. So if this fails, then we test this. If this passes, we ignore this. That's the main difference between this and this kind of a setup. With this setup, we're performing the test every single time. Now in this case, it doesn't matter too much, but well, let's say we have a scenario like this. We have some number, okay, and first things first, we want to test to see if some number is greater than 4. Maybe the next test, however, is also testing to see if some number is greater than maybe 2. Well, in this case, this passes and this passes, so we'd execute this code twice. Now that might actually cause a lot of problems. Perhaps we only want this code to be executed, and it would actually be the case that that would happen if we did like an if-else if. So if we change this to an if and then an else if, that would get rid of that problem. If the value was like 3 or something, okay, then this fails, and then we have no worries. But if this is 5 and we only want to execute this code and not this code, then we need to change this to an else if rather than just concurrent if statements. There will be scenarios where this is what we want, but it's important to note the distinction between the two. Okay, so the second thing I wanted to point out was nested if statements. So let's just get rid of this. We can keep it, but we'll comment it out. Now, realistically, we don't want to keep moving right or left forever. We reach the end of the screen and we probably want to stop moving. We don't want to go off screen. And so for that, what we're going to do is we're going to have an end position. So I'll have a constant end position equal to, let's say, 5. So what we want to do is only move right if we're at the end position, or if we're before the end position. As soon as we reach the end position, we'll stop moving right. For this, whenever we're moving right, we can actually have another statement. We can do an if x position is greater than or equal to end position, we are going to stop moving. Okay, so basically, well, you know what, why don't we change things up? Why don't we do this? If x position is less than the end position, then we'll do this. Okay. So here we are essentially testing two cases, and we're only moving right if both of those cases evaluate to true. So if the key press is right, and our x position is less than the end position, we're not quite there, then we'll increase by 1. So that's one way of doing things. Another way of doing things would be to add the logical AND operator. So let me just show you the difference between the two. We could start with, actually, let's just copy this, save some time. Key press is equal to R, and x position is less than our end position. So if that's the case, then we can do this, we can do that, we can tab this guy over, and that's basically doing the same thing for us. However, there will be scenarios where this is preferred over this, and where this is preferred over this. The problem with this is that we're only executing this code if both of these pass. However, with this case, we can actually still execute some code down here before the other if statement. So even if this passes and this fails, we might still want to execute this code here. So that is pretty much what we wanted to cover. We talked about concurrent if statements, we talked about our nested if statements, and we talked about how to use our logical operators to add additional cases. You can also substitute in the OR, although realistically that doesn't work in this context. You definitely want the AND operator because you want both of these to be true, but the OR works in, it would be used in a similar sort of scenario. So that's it for this. Your homework now, or your little assignment if you will, is going to be to implement this same logic, but in this case. So just like we don't want to go all the way off to the right hand side, we don't want to go off to the left hand side. So basically just implement the same logic in this if statement. Feel free to convert things to do this, test both, okay, or have the nested if statement. It's totally up to you. In our scenario here, it doesn't really make a difference, but in some cases it might. Okay, so once you've done that, feel free to move on to the next section where I believe we'll be introducing the concept of loops. So stay tuned for that. Thanks for watching, and we'll see you in the next one. What is up, guys? Welcome to part 12 of our JavaScript language basics. Here we'll be talking about while loops, and we'll also introduce the concept of loops to you guys, as this may or may not be the first time you've encountered them. So what are while loops? Well, while loops, or loops in general for that matter, provide a way to run code multiple times. So essentially, we write the code once, we execute it, and it continues to run over and over again until some condition is met. Now, while loops work very, very similar to an if statement. We perform a test, and we execute some code if that test returns true. However, the difference is that whereas if statements execute the code only once and exit, while loops will continue to execute that code as long as a condition is true. So while some condition is true, we execute the code, and we essentially only break out of the loop once that condition is false. This could actually lead to problems, whereas if the condition never ever evaluates to false, we never break out of the loop. But we will talk about how to fix that in the next section. So let's head on over to the code now. And this is where we left off last time. I asked you to come up with a solution to making sure we don't go off the left-hand side of the screen. Essentially, this is the reverse logic of the right-hand side. We're just making sure our X position is always greater than our start position. Okay, otherwise we just won't decrease it by 1. Okay, so it should be a fairly straightforward solution for you guys. I know you guys are very smart, so let's go ahead and move on. Actually, we can comment that out and then get back to the task at hand. Oh, actually, we do want to keep this around. Okay, so I figure for a while loop, we'll stick with the same movement example, okay, which means that we're starting at a position and we're trying to get to the end position. First things first, let's just take a look at while loop syntax. Note how it looks almost identical to an if statement, but we have a while instead of an if. We put the condition to test here and the code to execute in this body here. Alright, so again, we're trying to do a movement example, except that instead of just moving 1 unit at a time, we'll continually move 1 unit until we reach a start point, or the end point rather. So we'll have a constant to represent that end point. You know what, let's do end position, and we'll set that just equal to 5 so it doesn't run too many times. We'll have a start position, let's just call this one position, and we'll start at 0. So what we want to do is continually move forwards by 1, as long as we are not at the end position. So we can say something like, while our position is less than our end position, okay, we're just going to increase the position by 1. So position plus equals 1, like so. We can even simplify this and do position plus plus. There we go. That's even better. So, essentially, this will increase our position by 1 for each loop iteration until this evaluates to false. So the question becomes, how many times do you think this will run? Well, let's think about it. We start with position equal to 0. 0 is less than 5, so we increase it by 1. Then we go back to the top. Position is now 1. 1 is still less than 5, so we increase it and continue. So that's 2. Okay, increase, continue, that's 3. Increase and continue, that's 4, increase, continue, and then that's 5. Now 5 is no longer less than 5, so we skip this code, we break out of this, and continue with any code down here. Okay, so we get this running 5 times. It makes sense, because we start at 0, then go to 1, 2, 3, 4, and then by the time we hit 5, we don't run it anymore. Okay, so that's how a while loop works. It's actually very straightforward. As long as you can understand how if statements work, while loops work in that same way. Now the problem again becomes if while loops do not ever have a condition under which they will break. So if position will never ever be equal to end position, like if we did something like position plus plus then position minus, for whatever reason we wanted to do this, this loop would run infinitely, because position will never ever be greater than or equal to end position. This will never evaluate to false. There are workarounds, ways we can avoid such scenarios, and we should always build them into while loops. We'll actually explore those in the next section. For now, let's just assume that we are smart enough to build while loops that will not run infinitely. Now, let's make this a little bit more complicated. You can absolutely add other logic inside of a loop. We can even add extra loops within loops, so we can have loops nested within loops. We can go even further and have loops within loops within loops, but that gets a bit more complicated and our programs begin to run a little more slowly if that's the case, so we want to try to avoid nesting loops unless we absolutely have to. That said, we can build logic right into while loops pretty easily, and it doesn't necessarily run much slower. So I'm going to challenge you guys to do something a little above and beyond how simple some of the other challenges have been. What I want to do is essentially build a system where if we reach the end goal, then the game is over, or if we collide with an opponent, the game is also over. We'll still provide the same endgame logic. We're not really going to distinguish between winning or losing. What we'll do is we'll have an enemy position. Let's call this enemy position. Let's set this equal to 4. And what we want to do is within our while loop, we want to check to see if we ever hit our enemy position. If we hit our enemy position, then we want to say that the game is over. In fact, to make this easier for you, I'll add in another variable called isGameOver, and I'll set this equal to false. So what we're going to do is we're going to say while I'll get you started, while not is game over. So basically this is the same as saying, well, is game over is equal to false, then we want to do something. Now we're no longer going to be increasing position by 1, and actually what I'll do is I'll just copy this, and then I'm going to comment it out and paste it down here, while not is game over. Okay. What we want to be doing is still increasing the position, but we'll probably want to perform some checks. First of all, we want to make sure that we're not colliding with the enemy. If we collide with the enemy, or we reach the end position, then we want to exit out of this loop. So try to provide a mechanism by which we can do that. It's probably going to require an if and else if statements, and making sure that our current position is equal to the enemy position or equal to the end position or not, and changing the value of is game over. Okay, so give that a go. I'll of course provide the solution at the beginning of the next section, in which we'll be talking about different ways we can control our loops. So thanks for watching. We'll see you guys in the next one. What is up everyone, and welcome to part 13 of our JavaScript language basics. Here we're going to be covering the topic of control statements. This is kind of a continuation on the while loop tutorial, so we'll still use that code. So what are control statements? These allow us to exit loops or functions prematurely, or skip loop iterations. Essentially, they're in place to provide us finer control over how our loops and other control flow items work. So we're going to be specifically covering break statements, continue statements, and return statements. I know we talked about return values, but we're going to be expanding upon what the return statement really means and how to use it effectively. So let's head on over to the code. We'll start with a solution to the previous problem. Here we have a while loop. We're basically checking to see that the game is not over, so as long as this is equal to false. We are increasing X position by 1. This is a big assumption here, by the way, that the enemy is not right at position 0. I mean, that would really be kind of bad for us, because then right off the bat we'd be losing the game, but we're going to safely assume that that's not going to be the case. So we'll increase X position by 1, then we'll check to see if we are at the end, or if we have collided with an enemy. If we have, then is game over is equal to true, and then when we go to run this loop again, is game over is true, and so this is false, it fails, and so we break out of the loop. Okay, so this is just one solution of many. You could have done like an if else, and then done the X position plus equals 1 down here. There's lots of different variants of this, but this is one of a few different solutions. Okay, so we are going to look at an even better solution, and that is going to be through the use of break statements. So break statements, first and foremost, are going to be used to exit out of loops prematurely. So let's say is game over is never going to be equal to true. As long as we're running, our loop is never ever going to exit. Okay, it's always going to be running. However, at some point in time we want to exit out, so we might include a break statement. Maybe if we hit an enemy or something, we'll just simply break. Okay, it could be as simple as that, and then we'll have the end game logic down here. So let's rewrite the while loop to actually accommodate for that. So I'm just going to copy this, and we'll paste it down here. So basically we're going to still run while the game is not over, but we're not even going to bother with the is game over is equal to true. Instead, what we can do is just say break. Okay? If we really wanted to be specific and efficient, what we could do is eliminate this first case entirely. So we can just say, we don't even need the is game over variable then. What we can do is just say while X position is less than our end position. So as long as we haven't reached the end, we'll increase, and then we'll check to see if we hit an enemy. If we hit an enemy, then we simply break out of the loop, and this is the exact same logic. That way we don't even need the is game over variable, and we know that we can just exit out once we hit an enemy. Now, there's still no distinction between actually winning and losing here. That's fine. We'll get into that once we start building our actual game. The point is that a break statement helps us to exit out of a loop prematurely, even if this case has not yet passed, or not yet failed, rather. So our x position equals enemy position happens when our x position equals 4. And you know what? I've been saying x position this whole time. I have just been referring to this position variable. I guess I should have changed that. Okay. This occurs when this equals to 4, which is actually before this. So we'll break out of the loop before this ever returns false. Okay, and that's the power of the break statement. The continue statement, on the other hand, helps us to skip a loop iteration. So let's say for whatever reason, we want to skip a loop iteration when something happens. Let's say we are now, we have an end position of 10 now, okay? And what we want to do is continue to move forwards, and we want to skip every odd number. So what we can do is we'll just comment or copy this and comment it out, okay? We can say something like, well, x position is less than our end position, that's fine. We'll still increase x position by 1, but what we're going to do is we're going to skip every odd number. Now, we can do that before we increase the x position or afterwards. I think I'm going to do it before. I'm going to say if our x position mod 2 is equal to 1. We'll skip every odd number. I'm not sure if I said even or odd there, but let's only focus on the even numbers. So we only want the even jumps, okay? So using this, we can say basically if it's an odd number, we can just continue, okay? So what this will do is it will essentially skip all of this stuff. So using this, we're saying if it's an odd number, we're not going to execute any of this code. We'll simply move right on to the next loop iteration. Now, hopefully you can see a problem with this logic here. The problem lies in the fact that we will run into an infinite loop if we do this. Because as soon as we hit an odd number, we're just never going to increase x position. X position never changes, and so this, it just gets stuck here. It continues and continues over and over again. That's why we should probably do something different here. We can do, I don't know, x position plus equals 2 or something. Okay, just to mix things up, just for the sake of being a bit fancier. Again, realistically, we would just kind of end up increasing x position by 2 the whole time. We'd end up jumping. So this is definitely flawed logic. But the whole point was really to demonstrate the continue statement. The fact is that when we hit a continue, we skip everything else that's left in the loop iteration, and we go right on to the next one. Okay, so I just wanted to show you that. Because this is kind of a broken loop, I'm just going to get rid of that, and we're going to open up this guy again. Okay. So the final thing I want to talk about, let's see if I have enough time, I do really quickly, is going to be a return statement. So let's say we have a function, okay, and do something. Okay, do something like this, okay, and let's say it has some code, variable a equals 5. We're going to do something like variable result equals a plus something. Let's say we take in some number, some num, like this, and then what we're going to do is we're just going to say return result. Okay, so it's important to note that our function exits once it hits this. So even if we did something like a plus equals 10, this code will never ever be executed. And that's because a function, when it hits a return, breaks out of the function. Even if we didn't even return anything, and just did this, we're still going to break out of the function. A return acts exactly like a break does, but for a function rather than an entire loop. In fact, if we put a loop within a function, let's say we did this, okay, and what we're going to do, instead of function do something, and now I can comment this out, it's going to be move player, okay. What we can do instead of breaking is actually return. So I need to fix the indentation there. There we go, that's better. So instead of just exiting out of the loop, we can exit out of the entire function. This will return out of the loop and then the function. That's what this will do. But it's different from a break. A break only exits out of the control flow. Return exits out of the function. But my main point here is that a return functions like a break. It just exits out, and any code after it will never get executed. Okay, just as long as we know that, then we're good to go. So that's pretty much it for this section. We are going to skip the challenge for now and maybe reopen the challenge in the next section when we talk about for loops and for each loops. Okay, so stay tuned for that. Thanks for watching, and we'll see you in the next one. What's up everyone, welcome to the 14th part of our JavaScript language basics. This will be all about for loops. They act kind of like while loops but have some pretty distinct differences. So what are for loops? Well, in principle, they work similar to while loops. It's really just a way to execute some code or some lines of code over and over again a set number of times. The difference is for loops have a predefined start and end point and an iterator. This means they don't ever run forever. We know exactly when they'll start, exactly when they'll end, and typically we attach an iterator variable to help us to determine which iteration we're on. This is different from while loops. While loops have no predefined endpoint, no predefined start point or iterator. It's up to us to just make sure that a condition will occur at some point that will break out of the loop. So essentially, if we know exactly how many times we want a loop to run, we use a for loop. If we're not 100% sure how many times it will run, we use a while loop. Now, for loops pair very well with arrays because we have a start and end point and an iterator. We can essentially start at the beginning of the array, end at the end of the array, and iterate through each member. There's actually a specialized for loop to help us to do this. That is the for each loop. In fact, it acts kind of like a function that is attached to every single array. It allows us to just visit every single member from start to finish without having to explicitly say so. So we'll take a look at how to do a for loop, and then we'll take a look at how to do pretty much the same thing using a for each loop. So let's head on over to the code now. There was no challenge to solve at the end of the previous section. I'll be sure to provide you with one this time. It will be hopefully a little more complex and interesting, but first things first, we need to learn about these loops. So a for loop is structured kind of like this, at least the generic for loop. We have for, we have the start, the end, and the iterator. And then we have the actual loop body in here. So the start point is typically declaring a variable that's going to be the start. So often this is something like variable I equals 0. You'll very often see for loops start like this. The end point will be once I reaches a certain value. So I is less than some val, whatever that may be. And then the iterator, more often than not, is just I++. So this means first loop iteration, I is 0. We execute the code, then we go to the next loop iteration. I++, so I is equal to 1. Is it still less than some val? If it is, then we keep going, then it's 2. Is it still less than some val? Then we keep going, then it's 3, then 4, then 5, etc. until this fails. Okay, so this is kind of like a while loop. In that this is kind of the while loop condition. So while I is less than some value, we execute this code, increasing I by 1 each time. So this means that every for loop can be converted to a while loop, but not every while loop can become a for loop. It's important to note that. Okay, so for this, because for loops pair so well with arrays, I figure why not use an array and demonstrate the two together. So what we're going to do, actually, rather than create an array, is create a dictionary. So we're going to have a dictionary that's going to be our inventory. Okay, and we're going to place some items within it. First item, doesn't really matter what we put, we're just going to do maybe clothes. We have 2 clothing items. Maybe we have some kind of tools. We have 3 kinds of tools. Maybe we have some kind of food. We have 5 food items. And maybe we have just the 1 weapon, so we'll do weapons 1. Okay, so we've got a bunch of keys and value pairings. Okay, so we can get the keys, we can get the values, we know exactly how to do that. We can get them both, and maybe our job here is going to be to tally up the total number of items in our inventory and say we have X items. So we need to do a few things here. First things first, we need to get just the values. We're not interested in the keys for this particular task, so we just want the number of items total. So we need to get the keys. We'll say keys is equal to our object.keys, and we're going to get that from inventory. So this you should have remembered from the dictionary tutorial. Okay, it's just a way to get all of the keys. Now that we have all of the keys, and actually we don't even want the keys, we want the values. So object.values of inventory, because we want all of these guys. So we have an array of 2, 3, 5, and 1. Okay, so it looks exactly like this. So what our goal is to iterate through this array, add all the numbers together, and then produce some result. So we'll have a variable total items equal to 0. Okay, so we start with a variable I equals 0. We do want to start at index 0. We want to run until we reach the end of values. Lucky for us, we could just do values.length, okay, and that provides exactly what we want, because I will be equal to 0, then 1, then 2, then 3, and then once it reaches 4, it's no longer less than values.length, and so it breaks. Okay, so now what we want to do is get each of the values here. So we'll just create a variable called, let's call this quantity. This is going to be equal to values at the index of I. So when it starts off, it will be the values of 0, which will be 2, and that will be stored in quantity. Well, then we'll just take total items, and we'll do plus equals quantity. Okay, and that's it. That's actually all we need to do. So the way this will work is I will start off at 0, and values of I will be values of 0, so that will be 2. We'll add 2 to total items. Then, that's the end of the loop iteration. We go up to the top, I increases by 1, and so I is 1. Then we'll do, still less than length. We'll do values of I, so that will be 3. We'll add that. Then we go up to the top, I becomes 2. So we get 5, I becomes 3, we get 1, and then I becomes 4. Well, that's the end of values, so we exit out. Alternatively, it doesn't really apply in this case, but we can also use break and continue statements, just like we did with while loops. They're totally valid in for loops as well. It's just they're not needed to make sure that we exit prematurely. Okay, with a while loop, if you're not careful with break statements and continues and how you're building the loop, you could run infinitely. That's never going to be the case with a for loop. Okay. So then at the very end, we will have totaled up 2, 3, 5, and 1 to get, what is that, 6 plus 5, that will be 11 items total. Okay, so we just used our for loop nicely as long as we get the start point, the end point, we can get each individual item and then just add it to quantity. In fact, we could just do total items plus equals values, but I like to break it down step by step so that you guys can see exactly what's going on at each step. Okay, so that's a basic for loop for you. We are actually getting really close to the cutoff. So I'll very quickly introduce the for each loop and set you a task. So if you don't complete this task, that's totally fine. I know this is a little bit rushed. So the way a for each loop works is we attach it to an array. So in this case, we have values. So we could do for each, like so. Now for each takes in a function. Okay, the function can take in some parameters. In this case, it will just take in an element because it's saying values is just an array of values like 1, 2, 3, etc. Okay, so each of these is just a single element. If we did an inventory for each, the function would contain key and value. And that's because for each of the items in an inventory, it's a key and a value pair, so there's two separate values there. Okay, however, we are just dealing with arrays, or an array of values. So we'll do a values for each as a function, that's the elements, and then we can do whatever we want with these. If we wanted to print out each element, we could. Okay, what we're going to try and do is go one step further than printing. What I'd like you to try and do is take each item in the inventory, and I want you to increase its value by 1. So I want you to increase clothes by 1, tools by 1, food by 1, and weapons by 1, so we should get 3, 4, 6, and 2. Okay, so I know that may seem like a daunting task, but just try to break it down piece by piece. Essentially, we'll get the we'll need to probably get the keys. Okay, we can access the inventory items and the values by their keys. We know they exist, so we can just increase that key value by 1. Okay, so give that a go. Like I said, I know it's kind of a lot thrown at you all at once in a short time, but if you can't get it done, that is totally fine. It should not be too difficult if you remember how dictionaries work, and if you consider the fact that for each will visit every single member. So that's kind of the nice thing about using for each rather than this. We don't have to specify the start, endpoint, and iterator. For each knows to start at the start, it knows to end at the end of the array, and it knows to visit every single member. Okay, so give that a go. I will of course provide a solution for you guys at the beginning of the next section. Otherwise, that is it for now. Thanks for watching, and we will see you in that next one.